Okay, so there's something called the second derivative test that often is actually easier to use for finding local max and local min points. So let's think about how this would work. If we have a point that's a max, so here's my point where the first derivative is 0. Well, notice that the second derivative is negative. So if I can find a point where the first derivative is 0 and the second derivative is negative, I will know I have found a local max. And then if I find a point where the first derivative is 0 and the second derivative is positive, then I will know that is a local min. So this is another way to detect a local max or local min. So the way we did it previously was we found the divider and we had to check the first derivative in this area and in this area. So we had to do 2 tests. So you can see that the second derivative test might be more efficient because you only have to do 1 test. Once you find this point where the derivative is 0, all you do is then check what is the second derivative there, and it's 1 test. Okay, so let's look at how that will work. So let's follow the instructions here. Find all critical numbers. So that says find the first derivative. So I'm going to have 2x squared plus x minus 1. Then to find critical numbers, I need to set the first derivative equal to 0. So that's going to happen, let's see, factor and use the zero product principle. Either 2x minus 1 equals 0 or x plus 1 equals 0. So add 1 and get 2x equals 1. Divide by 2 and get x equals a half. And x equals negative 1. So my critical numbers are x equals a half and x equals negative 1. Then use the second derivative test on each critical number to decide whether it might be a local max or local min. So let's put negative 1 and 1/2 on our number line. And what we know so far is the first derivative is 0 when x is negative 1, and it's 0 when x is a half. And this would be a really good moment to check and make sure the first derivative really is 0 when you put 1/2 in and when you put negative 1 in, to check and make sure you have the right critical numbers before you go on. So then we need to find the second derivative, and that's going to be 4x plus 1. So now I want to know, what is the second derivative at the critical number of negative 1? So I want to know, what is f double prime of negative 1? So it's 4 times negative 1 plus 1, which is negative. So I know that at the critical number x is negative 1, the second derivative is negative. And then let's check the second derivative at 1/2. And that's positive. So let's see what we can determine. When x is negative 1, the derivative is 0, the second derivative is negative, so I'm concave down, right? If the second derivative is negative, I'm concave down and I'm at a point where the derivative is 0, so f has a local max here. And now I'm concave up and I have a point where the derivative is 0. F double prime is positive, F prime is 0. So we have a local min when x is 1/2. Okay, so we were asked to determine whether we had a local max or min. So that's what we have found. So let's write our answer out clearly that F has a local max when x equals -1, and F has a local min, has the local max when x is 1, oh, that's right, -1, and the local min when x is 1/2. Okay, so let's look at the graph. So when x is -1, there's the point where x is -1, and sure enough, we have a local max. And then when x is 1/2, we have a local min. Okay, so let's do one more example. Here's my function. And I'm going to rewrite my function as x plus 4x to the -1. Okay, so my first derivative is going to be 1 minus 4x to the -2. And I need to find critical values, so I'm going to set this equal to 0. So I'm going to write it without a negative exponent so I can figure out how to solve it. In general, if the variable you want to solve for is in a denominator, you should multiply both sides of the equation by any denominators. That's how you get it out from being in a denominator so that you can solve for it. So you're going to want to multiply both sides here by x squared. And I can do that because x can't equal 0. X equals 0 is not in the domain of the function, so it's okay to multiply by x. So then I'm going to get x squared minus 4 equals 0. This I know how to solve. I'll have x plus 2, x minus 2. So x is plus and minus 2. So I have two critical values, +2 and -2. So hopefully you're seeing how dangerous it might have been to solve and say x squared is 4, and so x is 2. As soon as you're missing one of your critical values, this process is not going to work for you. Okay, so we have two critical values, -2 and 2, and these are x values. And our first derivative is 0 here. Okay, now let's do our second derivative. The derivative of the 1 is 0. Then I'm going to have -4 times -2 x to the -3. So I'm going to have 8 over x cubed. So now I want to check and see what f double prime of -2 is. And the negative number cubed is negative. So f double prime is negative when x is -2. And f double prime of 2 is 8 over 2 cubed. So that's going to be positive. So I pretty much always still draw pictures of these to make sure I'm interpreting it correctly. F double prime negative is concave down and derivative is 0. So this is a local max. Then F double prime positive is concave up and the derivative is 0. So that's a local min. So we would say F has a local max when x equals -2, and F has a local min when x equals 2. Okay, so lots and lots of practice. The more you practice, the faster you get. And make sure and ask questions if you have them.